mathematical model of level process. This is the level process. A storage tank is called a level process. Sometimes it may be called as single capacity level process. Single capacity level process. Single capacity means single tank. It has inflow rate, that is Q in, so many liters per hour or liters per minute or kg per minute. If it is mass flow rate means kg per minute, kg per hour, like that. Q in. There will be outflow rate also. There is a outflow rate. The outflow rate is Q out. That is also in liters per hour. Volume flow rate, that is called volume. Liters per hour means volume flow rate. Kg per hour means mass flow rate. So level in the tank is H. Level in the tank is H. This is called level process. Level process. We have to obtain the mathematical model of this from the first principle. The first principle here is conservation of mass. Mass inflow rate. The difference between mass inflow rate minus mass outflow rate equal to rate of change of mass inside tank, inside process. Mass inflow rate minus mass outflow rate equal to rate of change of mass inside the tank. This is conservation of mass. We know that energy neither be created nor destroyed. Similarly, mass neither be created nor destroyed. It can be converted from one form to another form, but we cannot destroy that. So mass inflow rate minus mass outflow rate equal to rate of change of mass inside the tank. Let the density of that liquid entering the tank is rho. Rho is the density of the fluid. Here density of the outflow rate also rho, let us assume constant. There is no change in density of the liquid. While entering, its density is rho, while leaving, its density is rho. Therefore mass inflow rate is rho Q in. This is volume multiplied by density equal to mass, minus rho Q naught equal to rate of change of mass inside the tank. What is the volume inside? Let us assume that the area of cross section of the tank is A meter square. H is in meter. Therefore volume is AH. The volume equal to AH. Mass inside the tank is rho AH. Volume multiplied by density is mass inside the tank. Here rate of change of mass. Therefore d by dt of rho AH. Rho is constant, A also constant, that's why we can write here rho A dH by dt. dH by dt. Here rho Qn minus rho Q naught. Rho getting cancelled. Therefore, Q in minus Q naught equal to A dH by dt. This outflow rate Q naught equal to Q naught is proportional to root H, nonlinear relation. Q naught is proportional to root H, square root of that level. Square root of that level. Proportional to root H, that is equal to B root H, where B is the constant of proportionality. Therefore, this is equation 1. Another equation is Q naught equal to B root H. This is second equation. These two together represent the mathematical model of level process. But Q naught can be substituted. If you substitute, then you will get Q in minus B root H equal to A dH by dt. A dH by dt. This is the mathematical model of level process. But if you want to design any controller for this, we need the transfer function. But we cannot obtain the transfer function. We cannot obtain the transfer function. Why? Transfer, if you want a transfer function, means first step is we have to take Laplace transform. We have to take Laplace transform. But we cannot take Laplace transform because of this nonlinear term. We can apply Laplace transform only for linear relations. We can take Laplace transform for linear differential equation. For nonlinear differential equation, we cannot take Laplace transform. We cannot apply. Therefore, it's not possible to find the transfer function at this stage. If you draw the relationship between inflow rate Q in and H, the relationship will be like this. It is not linear relation. It is not a linear relation. It is non-linear relation. Because of this B root H. Because of this B root H, its relationship will be like this. But any non-linear segment, if you consider a small segment of this graph, it appears linear. If you draw a tangent to this, it will be like this. That small section covered by this tangent. So if you talk only for that region, means you can consider the tangent as the mathematical model. The tangent can be considered as mathematical model. If you operate in that region, I am going to operate in this region. Then both relations satisfies that region. That's why instead of using this, I can use this. Instead of using this, I can use this. That process is called linearization. So instead of this nonlinear relationship, I want to have a linear relationship about this nominal operating point. If you draw slope here, the slope will be like this. If you draw the slope here, it will be like this. So slope is different at different operating point. That's why we have to obtain the model at nominal operating. Nominal operating point means we used to operate at 50% level, means that is called nominal operating point. Always I used to operate at 50% means this is 50% level. If I obtain the mathematical model at 50% and about 50% I am going to change very small amount means instead of using that nonlinear relation, I can use this tangent as the relation for input output. I can use. That is called linearization, I said. How to linearize that? We know that Q naught equal to B root H. B root H. That is nonlinear relation. I want linearize. Linearize means I will take ln on both sides. If you take ln on both sides, you will get ln of Q naught equal to ln of B plus 1 by 2 ln of H. 1 by 2 ln of H. Taking logarithm on both sides, we got this. Take partial differentiation on both sides, we will get ln of Q naught means if you do partially differentiate this, you will get 1 by Q naught. Ln of x, if you differentiate, you will get 1 by x. Dou Q naught, partially differentiate, equal to 1, it is a constant, that's why it becomes 0, plus 1 by 2h, already 2 is there, 1 by 2h dou h. This is partial differentiation. What is differentiation? Differentiation means what is dou Q naught? What is the meaning of dou Q naught? What is the physical meaning of dou Q naught? Huh? What is that? Rate. You are saying rate. Dou Q naught means mathematically dou. What is dx by dt we are writing? What is the meaning of dx I am asking? I am not asking dx by dt means what you are saying is correct. Rate of change, velocity. What is dx I am asking? Physical meaning of dx. Infinite small change. Dx means infinite small change. Dou Q naught means infinite small change. Very, very, very small. Infinite small. That is called infinite small. Infinite small change by Q naught equal to infinite small change in H by 2H. But I am assuming that infinite small change is also true for small change. This change I am taking for H, this much change I am taking for Q. This much change I am taking for Q and this much change I am taking for H. That is called small change. That is called small change. This dou Q naught is infinite small change. We cannot see in naked eye. That much small change, dou Q naught. But this is also true for small changes we are assuming, that is the approximation. Therefore, delta Q naught divided by Q naught I am writing. It is also true for small changes. This infinite small change is true for small changes. True for small changes. Delta Q naught means change in Q naught. Small change in Q naught. That is measurable. But dou Q naught is not measurable. That is infinite small change. That cannot be measured. So we are assuming that dou Q naught is approximated to delta Q naught. That is here in the graph you can see the tangent is this is tangent at all these points. That small range, delta H range, delta Q in is taken, in that it is true. Therefore, dou Q naught is true for delta Q naught. Delta dou H is approximated to delta H, but we can call this delta Q naught as Q naught. Q naught. This can be called as Q naught divided by Q naught equal to H divided by 2H. This Q naught is called nominal Q naught. Nominal. This H is called nominal. This delta Q naught, dou Q naught equal to delta Q naught at nominal operating point, that is H nominal, Q naught nominal. What? Let us assume that level is at nominal operating point, say 50%. Now level is at 50%, remains at 50%. Then the inflow rate is called nominal inflow rate. Q in N. Q in N, nominal inflow rate. That time, outflow rate also equal to inflow rate. Then only the level remains constant. That time the Q naught is called Q naught N, nominal outflow rate. That's why instead of Q naught, I am putting Q naught N. What is the difference between Q naught and Q naught N? Then it is constant. Nominal outflow rate means it is a constant, but here it is not constant. Here it is not constant. If you say Q naught, it is not constant, a variable. If you say Q naught N, it becomes constant. Because nominal level never changes. 50% level means 50% level. 50% outflow rate means 50% outflow rate. Even though level changes, Q naught N will not change. Therefore, this is called, this is a constant. This is also constant. Therefore, Q naught equal to Q naught nominal divided by 2HN multiplied by H. We got this relationship. This is constant. H nominal divided by Q naught nominal means, H means level. It is like pressure in a electrical circuit, voltage. Like that you can think. H can be like the voltage. Q can be assuming like current. Voltage by current equal to what? Resistance. Voltage also constant, current also constant, then it is a resistance. That is equal to R naught. Hn by Q naught nominal equal to R naught. R naught is the resistance for outflow rate. That can be represented in the diagram as R naught. That resistance is in that valve, hand valve. We are assuming. Actually, it is in the pipe also, but we are assuming that it is concentrate. That is called lumped parameters. We are assuming all electrical circuit also, we are assuming lumped parameters. The resistance is at one point, we are assuming like that only we are calculating, but actually it is not so. The resistance is distributed. It is not at one point. It is not at one point. While calculating what we are assuming that lumped parameters, that is called, we are assuming that the resistance is at one point. We are assuming. Like that, the resistance is in that valve, we are assuming. That is R naught. So that R naught equal to Hn, H nominal divided by Q naught nominal. So we can write Q naught equal to 1 by R naught H. 1 by R naught H. What is Q naught? Q naught is change in outflow rate. Change in outflow rate. What is small h? Change in level about nominal operate level. About nominal operate. That is very, very important. That small h is about nominal level Hn. Q naught also varies about Q naught nominal. Now we can come to that nonlinear equation. Let it be B. Let the relationship be B. Now we can come to that again, the first relation. What is that? Q in minus B root H equal to A dH by dt. This is nonlinear relationship. This can be written as Q in nominal plus Q in. It means what? At nominal level, inflow rate equal to outflow rate. Q naught nominal equal to Q in nominal. Therefore, I can write Q in can be written as total Q in. Capital Q in means total Q in can be written as Q in nominal plus Q in. About changes, it may be positive or negative. Minus Q naught can be written as, this is equal to what? This is equal to Q naught. Q naught can be written as Q naught nominal plus Q naught equal to A d by dt of H nominal plus H. Can I write like that? At nominal operating point, Q in equal to Q naught nominal. Q in nominal equal to Q naught nominal. That's why this is positive, this is negative. That's why these two getting cancelled. Therefore, I can write Q in minus Q naught, change in inflow rate minus change in outflow rate equal to A dH nominal by dt plus A dH by dt. This is also equal to 0 because if you differentiate a constant, Hn is constant. If you differentiate a constant, it becomes 0. Therefore, the equation is reduced to Q in minus Q naught equal to A dH by dt. A dH by dt. About nominal operating point. Equation for changes about nominal operating point. But Q naught we know. The relationship for Q naught is 1 by R naught H. 1 by R naught H. Therefore, we can write Q in minus 1 by R naught H equal to A dH by dt. It is a linear relation. Linear relation. Approximate linear relation. Here it is non-linear relation. Actually, it is a non-linear relation. But we are approximating about nominal operating point. It is true only for small changes. It is true only for, this equation is true only for small changes. This equation is true for small changes about nominal operating point. And it is a linear equation, that's why we can take Laplace transform now. Now we can take Laplace transform. If we take Laplace transform, what we will get is Q in of S minus 1 by R naught H of S equal to A S H of S. Assuming 0 initial conditions. Assuming 0 initial conditions. Otherwise, while taking Laplace transform of differentiation, you have to consider the initial value. We are assuming that 0 initial conditions, that's why we got this equation. What is the transfer function? Laplace transform of change in output or output by Laplace transform of input. Change in output by change in input. Transfer function is Laplace transform of output by Laplace transform of input. Here output is H of S. That's why we can write this equation as AS H of S plus 1 by R naught H of S equal to Q in, or we can say R naught A S H of S plus H of S equal to R naught Q in. We can say that R naught A, RA, simply you can call only one R, that's why we can say it is, instead of R naught you can say R also. RAS plus 1 multiplied by H of S equal to R naught Q in. This is output, this is input. Therefore, output by Laplace transform of output by Laplace transform of input. Laplace transform of input Q in of S equal to R naught divided by R naught A S plus 1. This is the mathematical model in transfer function model. Mathematical model level process in transfer function representation. H of S by Q in of S equal to R naught upon R naught A S plus 1. This is what is the order? First order. That's what I, while seeing the laboratory process, mathematically if you obtain the mathematical from the first principle, if you obtain the mathematical model of level process, you will get First order. That's why we assumed it has first order. Without telling all these things, I said it is first order. Minimum first order. Any system in the world, minimum first order. All systems in the world are represented by differential equation. That's why solving differential equation is important, because all systems are represented by differential equation. If you want to know the output of a system, means you have to solve the differential equation. Mathematically, how to find the output? You have to solve the differential equation. That's why in mathematics class, they are troubling you to solve the differential equation. That is the reason. All systems in the world, if zero order, algebraic equation. Zero order means algebraic equation. No system is zero order. At least first order in the world. Therefore, the differential equation is inevitable. That's why you have to solve the differential equation. That's why the entire 18th century is spent on solving differential equation. So this is the mathematical model of single capacity level process. Let us see once again. This is the level process. Inflow rate is Q in, so many liters per hour. Outflow rate is Q naught, that is also liters per hour. That is called the volume flow rate. If you want to tell in terms of kg per hour or mass flow rate, means you have to multiply by density rho. Rho is the density of that liquid. We are assuming that density of the liquid while entering and leaving are equal. That's why inside also same density rho. The first principle, conservation of mass, says mass inflow rate minus mass outflow rate equal to rate of change of mass inside the tank. Mass inflow rate is rho Q in, because Q in is the volume flow rate multiplied by mass equal to mass inflow rate, mass outflow rate. The difference is equal to rate of change of mass inside the tank. That is d by dt of rho AH. AH is volume multiplied by rho mass. Rate of change of mass, that's why d by dt. But rho is constant, that's why getting cancelled. We got Q naught, but we know that Q naught equal to B root H, therefore Q in minus B root H equal to A dH by dt. This is non-linear relation, that's why we cannot find, this is the mathematical model. This is the true mathematical model in differential equation, in time domain. I want in frequency domain, means I cannot find, because we cannot take Laplace transform, because it is a non-linear differential equation. So we have to linearize. By linearize, what we will do is, about nominal operating point, we are assuming that small change only happens about nominal operating point. That's why we are bring the level to that nominal operating point. About the nominal operating point only we are controlling. If you give a large change, say if you give 25% change, means it won't work. Because you see that out to 75%, what is the slope of the line? Slope of the line is different. It means gain is different. The slope of the line at 50% is different. That's why it will work for small changes, say 5%, 2%, 3% changes only it will work. So about the nominal operating point, we are drawing a tangent for the relation between Q in and H. The tangent is a linear relation. So instead of using this non-linear relation, we are going to use that linear relation, that is called linearization. How to mathematically obtain the linear relationship? For that we have to take Q naught equal to B root H, take ln on both sides, ln of Q naught equal to ln of B plus 1 by 2 ln of H. Partially differentiate on both sides, you will get dou Q naught by Q naught. Dou Q naught by Q naught equal to, this is constant, that's why differentiate 0 plus dou H by 2H. This is infinite small changes. Mathematically it is true for infinite small changes. We are assuming that it is also true for small changes. Therefore, that delta dou Q naught is replaced by delta Q naught. Delta Q naught by Q naught equal to 2 delta H by 2H. Delta Q naught is small changes about nominal operating point, that can be called as small Q naught. Capital Q naught is total flow rate. So suppose if it is 10 liters per hour, means that is called total flow rate. About changes about nominal operating point is 0.02 liters per hour. That is Q in or Q naught. Changes about nominal operating point. So that is delta Q naught. Therefore, delta Q naught by Q naught equal to, we are assuming that it is true. Delta Q naught by Q naught equal to delta H by 2H. But delta Q naught can be called as Q naught, small Q naught. Small Q naught divided by, this is true only at the nominal operating point. Already I told you that if you draw the tangent at different operating point, the slope is different. The slope is different. Actually, we are finding dou h by h, dou h by dou Q naught we are finding. This is slope. The slope is different at different operating point. That's why about nominal operating point, it is true for small changes. That small change can be called as Q naught. Therefore, Q naught divided by Q naught nominal. Q naught nominal means it is constant. Because at this operating point only it is true. H divided by 2h nominal. Or we can write Q naught equal to Q naught nominal divided by 2h nominal. This can be called as 1 by R naught. Therefore, Q naught equal to 1 by R naught H. We got another linear relation between inflow rate and the level. That can be used to find the linear relationship, linear mathematical model. So, instead of using B root H, we can put Q naught, but Q naught equal to can be written as Q in can be written as Q in nominal plus small q in. Change in inflow rate. Q naught nominal plus change in Q naught. This is constant. This is constant plus changes. This is constant plus changes. Therefore, it becomes variable. But at nominal operating point Hn, inflow rate equal to outflow rate. If level remains constant means inflow rate must be equal to outflow rate. That's why Q in nominal equal to Q naught nominal, that is getting cancelled because of different sign. In the right hand side, this is constant, that's why it becomes 0. Therefore, this can be written as Q in minus Q naught equal to A dH by dt. This is equation for changes. Equation for changes, it is a linear relationship. Equation for changes about nominal operating point. Now we can take Laplace transform. If we take Laplace transform, we used to write in caps. Laplace transform will be represented in caps. Therefore, the transfer function is equation for changes, not for total differentiation. It is for changes. Therefore, Q in of S minus 1 by R naught H of S equal to A S H of S. We took the Laplace transform assuming 0 initial conditions. Now, let us find the transfer function. Transfer function is what? H of S by Q in of S, that is equal to R naught upon R naught A S plus 1. This is called the time constant of the process. This is called a time constant. This is called a time constant. This is called the gain of the process. Static gain. Static gain of the process. Static gain of the process. Static gain, time constant is function of static gain also. That's why how we can change the gain. In the lab, this type of hand valve will be there. If you change that hand valve, the mathematical model will be changed. That's why you should not change that valve openings. Are you able to understand? You see that what is the time constant relation for time constant? R naught A. What is R naught? R naught is resistance at outflow rate. That R naught, if you change the valve opening, you are changing gain and the time constant. So different mathematical model. That's why don't play in the lab. If you play in the lab, you cannot finish the experiment in 3 hours because mathematical model must change. You are getting different mathematical model for different settings. It won't work. Because the time constant is very large. In electronics lab, if you do any play, immediately you can connect and you can get the result immediately. But here it is not possible. You have to wait. Your patience is required. That's why don't play. Don't change R naught. Don't do any changes in the process. It will change the parameters. That's why it will not work out. Again you have to do. Again you have to spend 3 hours. That's why don't play. That's why I am telling. So the R naught is static gain. R naught A is time constant. You won't change area of cross section. That you can't change. But you can change R naught. But you can change R naught.